I really don't have to cut all that out.
You don't have to. It literally takes up 2 seconds of not doing anything.
40 minutes.
Exactly. It's like 2 seconds out of 40 minutes. Don't think it matters.
Okay, now as opposed to a lot of the questions which we do, which are College Board lookalikes. Okay, this is Princeton Review's idea what a College Board question should be, or Barron's idea what a College Board question should be, or Peterson's idea what a College Board question should be. All of the questions in this packet came right from the College Board. These are right off of AP Exam. So these will give you a real good sense of what College Board questions are.
Alex, you know what you always said? We had less questions to do over break than we did for this weekend.
Okay, for the first one. Highway curve has a radius curvature of 100 meters. Is backed at an angle of 15 degrees as shown above. Determine the vehicle speed for which the curve is appropriate if there's no friction between the tires and the vehicle. Okay? So basically, what's the banking equation? Okay? I have a situation here where my normal force is providing all of the centripetal force. So my normal force is mg tangent theta, because there's your normal force, okay? There's mg. This is the centripetal force. So your force triangle flips around with banked roadways. And our normal inclines, gravity provides the hypotenuse to the triangle. With your banked equation, the normal force provides the hypotenuse, and the weight is only one of the two sides. The weight is one side, the centripetal force is the other. So the tangent function of this side is this, which is the centripetal force. So F sub g, which is mg, times the tangent of theta, is equal to your centripetal force, which is mv squared over r, which then gives you v squared is equal to rg tangent theta, where v is equal to the square root of rg tangent theta.
Couldn't you solve that?
The way we saw it, in the textbook was v squared is equal to tangent
theta equals v squared over rg.
v squared over rg. Yes.
You could actually find the numbers for that. Yeah. They give you information.
Oh, okay, so we can. So okay, I should go down and find a number. Yes, because I know what r is, I know what g is, I know what theta is, I know what theta is.
We got 16.2.
Did everyone else get 16.2?
Yeah.
Woo!
So what was the answer?
We believe 16.2. 16.
I've got my examiner's reports in here. No, I don't. Okay, I'll check. Okay, on the diagram below, okay, on a day when the friction is present. That's right, I did solve for that.
Video probably can't see anything on the projector.
When you have no friction whatsoever, the safe speed is 16 miles an hour, 16 point something. Okay? Now, on a day when friction is present, you're going to navigate this much faster because friction is going to help out by providing some of that centripetal force. So you can go around it much faster without spinning out. You're going to be able to go down around it at 25. So on the diagram below, draw and label the forces. This is a free body diagram.
Why is it centripetal force labeled?
Because centripetal force is not a freestanding force.
Remember, it doesn't
Centripetal force
exist.
is always caused by something else.
The cake is a lie.
The centripetal force here is a combination of the normal force, or the force of gravity, and the frictional force. Okay, you should never label centripetal force as a freestanding force on a force diagram, because centripetal force is always being provided by something else. In this case, it's being provided by the normal force and by the gravitational force, or by the frictional force. Okay, if you take a look at the breakdown, you can kind of see where it's all coming from. Okay, this is your frictional force here,
I did not get anything.
okay? Part of that frictional force can be directed towards the center of the circle. So part of this force here is centripetal force. And then part of the normal force is centripetal force. So it is these two components of the normal force and the frictional force that provide the centripetal force. So your centripetal force is the frictional force divided by the cosine function, and it's also the weight force times the tangent function. And then you just substitute your numbers in, and you'll get, I did solve for this one for a final 131. But here's the theory of it. Right here, this will get you probably half the points that are allotted for that. I don't know how many points were given for this part of the problem. But that would get you probably 2/3 of those points. That relationship right there. And then the other 1/3 will be coming from just coming up with a number answer and substituting it properly. Most of the credit on any AP question is for the setup of the problem. And this is why the AP people will tell you you should be spending 2/3 of the allotted time setting the problem up. And then the remaining 1/3 of the time just plugging the numbers in. So on a 15-minute question, 10 minutes of it should be done in setting it up. And then the other 5 minutes you just plug the numbers in and get your answer.
Yeah, at the end of January. What?
Okay, what the AP people do a lot is expects you to be able to relate angles to particular phenomena. So for instance right here, okay, I've got a ball of mass m released at rest, a distance h above a frictionless plane, inclined at an angle of 45 degrees. Well, that 45-degree angle is important because the fact that it's a 45-degree angle allows you to say that your vertical velocity and your horizontal velocities are the same. Because, well, we'll go down. The velocity of the vector of the ball just after it bounces off point P. Well, when it hits, okay, that velocity there bounces out at 45 and 45. So my PE is equal to KE, get my velocity, okay? My velocity is this horizontal velocity, right here, because it bounces out horizontally. So this velocity here, which is the velocity at point P, is this horizontal velocity here. Because of the 45-degree angle, it is also the vertical velocity here. Your horizontal component of velocity and your vertical velocities are the same because of the angle, because of the 45-degree angle. So, using that, okay, the plane is inclined at 45 degrees, so that your horizontal displacement is equal to your vertical displacement. Your horizontal displacement is subject to just plain constant velocity, so Vt. Your vertical motion is accelerated, so that the vertical displacement, which is a horizontal displacement, Vt, is equal to 1/2 gt squared. Solve for t. So that 45-degree angle allows you to equate the vertical velocity, the horizontal velocity, the vertical displacement, the horizontal displacement. And it's those kind of jumps that the AP people are expecting you to be able to do. The distance along the plane from P1 to P2, okay, well that distance is either the horizontal distance or the vertical distance because they're both the same. If I take the horizontal distance, there's my horizontal velocity. There's the time. Okay, if I do my vertical distance, there is the time.